All right, so our coordinates, our ordered pairs are in x, y, alphabetical order, the x and the y. This is the x, this is the y. If you forget which one is which, one of my teachers taught me that this is the y and that's the x, right? So the x is describing how far you go out and the y is describing how far you go up to get to your point. Now, you can eliminate a lot of these possibilities by just knowing that, because take a look at C. Isn't C at the same height as D? That means that its y coordinate, this guy here on the y, is going to be the same as the y coordinate of D. So the y coordinate must be 4. And so there's only one guy who has that 8 there, so that's kind of ridiculous. We just knock him out, and now we still have 3 left. So then the x coordinate, we have to determine how far out this is. How far on the x does it go? Well, we know that it's got to be bigger than 6, right? Because this guy here is out 6 on the x. So this point has got to be bigger, so it can't equal 6, otherwise it would be straight up there. So this guy's out, but by he goes. Now, debating between this one and this one, you might have a good guess that 12 seems kind of way too far out. The drawings on the CSET are drawn to scale unless it's mentioned otherwise. So we have a pretty fair guess that our answer is C, and that would be an excellent guess, and it turns out to be right. But to verify it, they give us the information that this is a parallelogram, and we have lots of properties of parallelograms, and I have a whole other video about all the properties of parallelograms. It's not too important for this test, but it's interesting. The most important ones are, yes, the opposite sides are parallel, hence the name. So these two sides are parallel, they never touch. Those two sides are parallel, and they never touch. What might help us more here is that their lengths are, opposite sides are congruent. They have the same lengths. So this length is equal to that length, and this is equal to that. So if I'm thinking that this length here is supposed to go from an x-coordinate of 2 to an x-coordinate of 6, right? Then the length should be 4, right? From 2 to 6, that's 4. So this length up here must be the same. He starts at 4, and if I add 4 more, I will get 8 for the x-coordinate. So not the prettiest diagram, but we do confirm that it's 8. So we got that because we know for a parallelogram we have opposite sides congruent. You could also confirm, remember I said the parallelogram, the opposite sides are parallel. So for kicks, we can check, we know that if sides are parallel, they have the same slope, right? And we know that our slope is supposed to be rise over run. So let's just check this for kicks. This slope here should be the same as that slope there. Let's check. So this slope here, to find your slope, you're just going to take 2 points on the line. And I like to start with the bottommost point, that way I can see myself rising and running. So to get from this point to that point, I have to rise up 1, 2, run over 1, 2. So my rise over run is 2 over 2. To get from this point to this point, I have to rise up 1, 2, run over 1, 2. So that is also 2 over 2, which both simplify to 1. Heck yeah, they have the same slope. Now I just realized that I'm doing it on my whiteboard with grids on them, and you don't really have a grid on your test paper. So you could draw a very, you just do your best to draw tick marks underneath so that you could do it. There's also a formula that your slope, when we say the rise over the run, the rise is the change in the y values, and the run is the change in the x values. Man, this is getting messy. Hold on, sorry. So if the rise is the change in the y values and the run is the change in the x values, some of you guys know this formula, y2 minus y1 over x2 minus x1. That's the difference in the y values over the difference in the x values, the rise or the run. The formula looks scary, and so I really don't encourage people to memorize it. This is all you need for the CSET, and if you had to do Algebra 1 later, if you had to teach this formula, I really stress teaching it from that definition. But you could check it this way just because we've come this far. So if I wanted the slope of AD, I could take 2 points on that line. So I could take the 4, 4, and the 2, do that, doesn't matter actually, it doesn't matter which one I wrote first. So this is my first x, and this is my first y, this is my second x, and this is my second y, hence my x1, y1, comma, x2, y2. So when I find my slope, I take the difference in the y's, so y2 minus y1, so subtract those y's, 4 minus 2, and then subtract the x's, also 4 minus 2. Not the best example here because they ended up being the same, but that's that. And then if we did the slope of BC, just checking to see, going from 8, 4 to 6, 2, this is my first x and my first y. This is my second x and my second y. So when I find my slope, I just take the y's and subtract them, 2 minus 4. And if I started with this point, start with this point again, so 6 minus 8. And so 2 minus 4 is negative 2, 6 minus 8 is negative 2, but a negative 2 divided by a negative 2 is still a positive 1, since a negative divided by a negative is positive. So yes, the slopes are the same, so yes, the lines are parallel, and yes, I totally belabored that problem, but hopefully it was interesting.